Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In today's video, we are discussing a paper 4, that is a mechanics paper. It's of October-November 2024, variant 42. Let's look at the solution. Question number 1, that looks like a velocity time graph. Yes, it is. And let's read the question. The velocity of the particle moving in a straight line at time t seconds after leaving a fixed point O is v meter per second. The diagram shows a vt graph models the motion of a particle from t is equals to 0 to t is equals to t. So t is equals to 0 to t is equals to t. The graph consists of 4 line segments. That is the first one, second one, third one, fourth one. 2 line segments are above the x-axis, 1 line and 2 line segments are below the x-axis. All the information is given. It accelerates from rest to a speed of v over a period of 4 seconds. That's the first one. Then decelerates at this acceleration to instantaneous rest over a period of 6 seconds. So 4 plus 6 is 10. The particle then travels back. Therefore, the direction is changing. So area above the graph, we consider it to be positive. Area below the x-axis, that is negative. That shows that the direction has changed. It's now turning around. And there are 2 portions over here, reaching a maximum speed of 3. So speed is 3 since it's in the opposite direction. Therefore, velocity is negative 3 before coming to rest. And that is coming to rest over here. Find the value of v. So now we are using this blue triangle to find the value of v. Change in velocity over change in time is the magnitude of this deceleration. V comes out to be 10. Some people, they prefer to use coordinate geometry, take care of the negative sign as minus 5 over 3. That is also perfect. Given that the total distance traveled is 68 meters, find the value of t. That means when we talk about the distance, we take the positive value. We should also take the positive value, add it up individually. So now this is 10 seconds. This is 10 meter per second. Area of the red and the blue, area under the red and the blue line segment is 50 meters. 68 minus 50 is 18 meters. That is on the way back. That should be the area of this triangle. So now the height is 3. The base is t minus 10. These are labelings. This is all the way up till here is t. All the way up till here is 10. So the difference is how much? T minus 10. Half into 3 into t minus 10 is 18. Therefore, t comes out to be 22. Question number 2. A block of mass 20 kg is held at rest at top of a plane inclined at 30 degrees to the horizontal. So that is the starting point. The block is projected. It's not released from rest. It is projected with a speed of 5 meter per second down the line. There is a resistive force acting on the block. The block moved 2 meter down. So this AB is 2 meters. That is what I have labeled from myself. The work done against this resistive force is 50 joules. Find the speed of the block when it has moved 2 meters down the plane. Simple work energy principle. Total energy at the start, that is kinetic energy at the start plus potential energy at the start, half mv squared mg sine theta into distance along the plane. Similarly, total energy at B, we are finding for this particular value the unknown velocity or the speed, and potential energy at B is 0 because this is the base level. Work done against resistance is 50. Total energy at the start minus total energy at the end is work done against resistance. You can leave the answer in the exact form or leave the answer correct to 3 significant figure. That's your choice. Question number 3. Now it says a cyclist is riding along a straight horizontal road. The total mass of cyclist in his bike is 90 kg. The power exerted is 250 watt. At the instant when the cyclist speed is 5, his acceleration is 0.1. So it's an application of F is equals to ma, and power over velocity is the force produced by the engine. So 250 over 5, that is the force. This is RF, resistive force, mass into acceleration, that is 90 into 0.1. Simple calculation, even without a calculator, RF is 41. The next part. The cyclist comes to the bottom of a hill inclined at 2 degrees and underline few things. So now it's the hill is inclined at 2 degrees given that the power and the resistance are unchanged. So power and resistance are unchanged. Find the steady speed, the constant speed. That means acceleration is 0. Find the steady speed which cyclist could maintain when riding up the hill. So now this is the power divided by velocity. That's the force produced by the engine. We are looking for V. Not only it has to overcome the resistive force, it also has to overcome the weight component. So our power over velocity minus resistive force minus weight component is mass into acceleration, which is 0 because it's constant speed. Therefore, V comes out to be this. Write everything in the exact form, use a calculator, write the answer correct to 3SF. Let's move on. Nice question. Question number 4 was a nice question, came after a long time. Now it says, the diagram shows two particles A and B of masses such and such. The particles are suspended below a horizontal ceiling, that's the ceiling. And the angles are given 45 degrees and theta degrees. Let me just do one thing over here. So this is also 45 and this is also theta, because I believe in working with angles with the horizontal. First thing, find the tension in the string AB. So tension in string AB, I have labeled this as T1. Tension in string, AB is actually this one, my bad. So let me label it properly. Tension in PQ, the red one. So which colors are there? There is a red color, there is a green color, there is a blue color. There are three colors over here. So therefore tension in PQ, PA, I have labeled this as T1. Tension in AB, I have labeled it as T2. Tension in BQ, I have labeled it as T3. That will be coming on the next page. So now it says, find the value of tension in the string AB. So that is T2. So just focus on the particle. That's where the magic lies. What are the forces acting on it? The weight, tension pulling to the right, and this tension over here. It has nothing to do with the blue tension as such. So now this force needs resolution. This is T1 cos 45. This is T1 sin 45. This is T2. This is 0.2 G. T2 is T1 cos 45. And T1 sin 45 is 0.2 G, which is 2. Isn't T1 sin 45 and T1 cos 45 the same? Yes, it is. Why? Because the value of these two is exactly the same. It's a special angle, 45 degrees. Therefore, what is T2 equals to? 2 Newton. No calculator was used in this part. Now the next one. Find the value of theta and the tension in the string BQ. Tension in string BQ is labeled as T3. So this is theta. This is the horizontal component in terms of cos. This is the vertical component in terms of sine. The horizontal will always be in terms of cos, provided I take angle with the horizontal. And the vertical will always be in terms of sine. This 2 Newton was found earlier. The weight over here is 1 Newton. One equation for horizontal, this equals to this. And the other equation for this one, divide one equation by the other so that sine over cos becomes tangent, and we find the value of theta. And if I want to find T3, I can use a calculator again, but I preferred to use the exact ratio. Tangent of theta is 1 over 2. 1 is opposite, 2 is adjacent. Therefore, hypotenuse is root 5, Pythagoras theorem. Sin theta, 1 over root 5. Cos theta, 2 over root 5. If I use the sin theta equation, sin theta is written as 1 over root 5. Therefore, T3 is root 5. If someone uses a calculator and take out the sine and cosine and all this thing, therefore, T3 comes out to be 2.24 Newton. Question number 5. Now, this time it's momentum in a vertical direction. Two particles P and Q, 2m and mkg. 2m and mkg, I have written the masses on the next page, are held at rest in the same vertical line. So they are one on top of each other. Which one is at the top, which one is at the bottom, we will soon find out. The heights of P is 1 meter respectively. The height of Q is 2 meter respectively above horizontal ground. Therefore, Q is 2 meters above ground, P is 1 meter above ground. Therefore, the difference between the two is 1 meter. Keep that in mind. Find the speed of each particle immediately before they collide. So this is a kinematics question. That is, displacement of Q plus displacement of P should add up to 1. So that is the working that we are doing. The total displacement adds up to 1 and we get t is equals to half seconds. That means in half second, P has moved up, Q has moved down, and they collided with one another. What are the velocities at this instant? Use the equation v is equals to u plus at. This comes out to be 5. This comes out to be -3. So now this was already coming down. And this is coming to be -3 because it was moving up and then it turned around. So both particles are coming down. Now this thing, that is for later. Yeah, I can just explain it right now. If I need to find the position of each particle when collision takes place, so let me use this one q because it's moving in this direction. Whatever the distance that it covers, if I subtract it from 2, I'll get the distance that is above the ground. So when I plug in t is half, this comes out to be 5 over 4. 2 minus 5 over 4 is 3/4 meter above ground. That means q is over here, p is over here. These two are 3/4 meters above the ground. It is given that immediately after the collision, the downward speed of q is 3.5. Now in this question, I'm taking downward velocity to be positive because everything is moving in that direction. So what's the use of taking upward to be positive and downward to be negative? So that's why it's the convention is in my hands, it's in my control. So I have taken downward to be positive. This is the mass of p, this is the mass of q. So before, after collision, momentum before collision equals to momentum after collision. They both are moving in the same direction. M into 5, 2m into 3. M into 5, 2m into 3. That is m into q, 2m into v. This is unknown. So now this is 3.75, but stop for a second. It's not over yet. This is the speed at the instant that it reaches the ground. This is the speed at collision, just after collision. So this is just after collision. Now on the previous page, we found out that the collision takes place when both particles are 0.75 meter above ground. That means this particle P, let me label it with red, and it's talking about P, not the green one, the red one. So it's talking about P over here. P has to move down. This is the speed with which it's moving down. Acceleration is pulling it down, acceleration due to gravity. And this is the distance. So therefore, V comes out to be 5.39 meter per second, correct to 3 SF. All good, all clear? Hope you're enjoying it. Mechanics is all about enjoyment and linking things together. Question number 6. A particle P travels in a straight line starting from point O with velocity 6. As soon as I have read it, I'll write these 3 things down. What 3 things are over here? The first one, when t is 0, actually 2 things. When t is 0, v is 6 and s is 0. Because it was at the origin, so displacement from origin is 0 and the velocity is given. So I'll be using it up later. Now there are 2 equations that we have to deal with. There is an equation for this time period. There is an equation for this time period. First of all, it says find the velocity of p at t is equals to 1. So t is equals to 1 is inclusive in the first equation. Integrate, there is a constant of integration. Plug in t is 0, v is 6. That is right over here. T is 0, v is 6, therefore c comes out to be 6. Therefore, I have this velocity equation. And what are they asking me? They are asking me find the velocity when t is equals to 1. So when t is equals to 1, velocity is 5. Now this will be used in the next part. It says given that there is no change in velocity of p when t is equals to 1. Therefore, this thing from the first part can be used for the later parts. So let me use it for the later parts. Now, again, we are finding the expression for velocity for t greater than 1. So this is the acceleration equation for t greater than 1. Integrate this thing. There is a new constant of integration which is k. And we have to evaluate k. So k is right over here. Let me tell you the process. Integrate, integrate, simplify. The integration is pretty basic. Cancel off the constants. 1.5, I wrote it as 3 over 2. So that it's easier for me to cancel it out. And then I have this equation, t is 1, v is 5, therefore k is 10, therefore the final equation is over here. So this is the final equation for the first second, that is between 0 and 1. So this is velocity equation 1 and this is velocity equation 2, because now both these equations will be used. Part C. Now what does it say? it says that given that the velocity of p is positive for t is less than or equal to 4. What does this word means? That means there is no change in direction. So you don't have to worry about the turning point and such things like that. Find the total distance traveled between t is equals to 0, t is equals to 4. So when you have to find the total distance between t is 0 and t is 4, so basically first find the distance between 0 and 1, because that is a separate equation for that one. And then find the distance between 1 and 4. So that is 4 over here and this is 1 over here. Got the idea? It is not one single equation, it's two different equations. The velocity equation 1 is used over here. Integrate again. It's all about pure maths. Integrate again, and then what do? You plug in the upper limit, you plug in the lower limit. Since when I plug in 0, these two terms cancel out, I simply wrote a 0. This comes out to be 28 over 5. Of course, you can use a calculator over here. But show all the steps. There is no compromise on the step. There is no limitation on using the calculator, but at the same time, there is no compromise on using the steps, showing the steps. Now the next thing, that is this big equation. There are 3 terms. Simplify. Unless and until you simplify, don't plug in the limits because you're going to mess it up. So that is the upper limit. That is the lower limit. That comes out to be this. And working in exact fractions, the answer is beautiful. It comes out to be 20 meters. Now let's look at question number 7. It says 2 particles. I'll go to the diagram in a short while. Let me first read it because then I get distracted with the diagram. 2 particles A and B of such and such masses are attached to the ends of a light inextensible string. It passes over a small fixed smooth pulley attached to the bottom of a rough plane. Inclined at an angle theta, sine theta is given. Particle A lies on the plane. Particle B hangs vertically below the pulley, 0.25 meter above horizontal ground. The string between A and pulley is parallel to the line of greatest slope. The coefficient of friction is this much. Particle A is released from rest. Find the tension in the string and the magnitude of acceleration. So now let's look at the diagram. This is the scenario over here. First thing first, sine theta is 0.6. I love working in the exact form whether the examiner asks for it or not. So this is 6 over 10, that is 0.6. Therefore, Pythagoras theorem gives me 8. Cosine theta is 8 over 10. Some people, they prefer using sine square plus cos square equals to 1. I personally prefer the triangle. Now over here, let me work with r because we are dealing with fractions. So r is a must. R is mg cos theta. So this is m, this is g, this is cos theta. I wrote it as it is. F max is mu times r. That is all these things multiplied together. Now let's analyze the situation. It's going down. That means mg minus tension is ma, and tension plus mg sine theta minus F max is mass into acceleration. So make an equation for each particle, add it up, you get the equation of the system. That is the equation for particle B. That is the equation for particle A. Add it up, the tension cancels out. 0.3 g plus 0.2 g sine theta minus F max is the total mass into acceleration. This is 1.2. So let me highlight it because it will be used up later. This thing is this thing. And this thing 1.125 F max, that is 1.8. And that gives me the value that A is 4.8 meter per second. And plug in one of the equation, the simpler one preferably, and we find the value of t as 1.56. That is the first part, 7 marks. I think that's a lot of marks for 7. I mean, you people are lucky, whoever gave this particular exam. Now it says, when B reaches the ground, it comes to rest. So now it's the same old story that we have the acceleration of the system. It traveled downwards. The distance is this. Acceleration is 4.8. Initial velocity is 0. Find the velocity with which the particle hits the ground. And what happens to this particle? So this particle will travel a little bit down before it comes to rest. So that is the story over here. Let me read the whole question. So it says, find the total distance that A travels down the plane when it is released until it comes to rest. You may assume that A does not reach the pulley. That means it stops before the pulley. So for particle B, U is 0, A is this, S is this. Find V, leave the answer in the square root form. No need of using the calculator. The string becomes slack, tension is 0. So now this equation over here, this thing is 0. So therefore 1.2 minus 1.8 is 0.58. I have written the whole thing over here. This is over here, this is 1.2 minus 1.8 is equals to mass into acceleration. Naturally, A is coming out to be negative. It's slowing down. Now the final velocity from the previous part becomes the initial velocity. Final velocity has to be 0. Apply the equation, v square is u square plus 2as, and s comes out to be 0.4 meter. That's not the answer, because total distance is the distance moved as a system. And this was the distance A moved as a free particle. So the total distance comes out to be 0.65 meter. So that completes this M1 paper, which is of May-June. Not May-June, this is October-November, my bad. So this is October-November 2024, variant 42, and it was a nice balanced paper. Stay tuned for more content on Mathematics with Shahab Yaqub.